started recording.
Okay, thanks. So welcome everybody and thank you for joining this grassification webinar on anaerobic co-digestion of roadside grass clippings. I'm Margherita Genoa and I work for Impact, which is the partner responsible for communication and dissemination activities within the grassification project. The event of today is a kind of part of a series of events that the grassification project is going to organize all over its final year, and which will be tackling different aspects of the project itself. But coming back to what we have prepared for you today, I would like to share the agenda, the very interesting agenda that we have today, which is structured as follows. We do have 6 panelists who are going to discuss with us the anaerobic digestion of grass and how roadside grass clippings can become a renewable, can be used as a renewable feedstock. After the presentation of the 6 speakers, we do have a Q&A session of about 20 minutes. So we really encourage you to write your questions in the chat box so that we can take them either after the presentation of the speaker or during the question and answers session. At the end of the event, we do also have an evaluation form that we prepared, and we really would ask you to fill this template with your feedback. That would be really helpful for us. This will only take a few minutes, and the link will be available in the chat box so that you can fill the template. For what concern other technical information, I would kindly ask you, I would kindly remind you that the session is recorded and that all the presentation will be available after the event. Now, without taking any more time for technical information, I would start introducing the first speaker of the day, who is Marcela Fernandez de Sousa. Marcela is a technical engineer with a PhD on technology of chemical processes. She's currently project manager at Ghent University, and her research interests are bioprocesses, biomass valorization, and resource recovery. And she will give us an overview on the grassification project itself. Marcela, the floor is yours.
Thank you, Margherita. I'll just share my presentation. Can you see my presentation?
Yes.
Yes, thank you. Okay, so good morning, everyone. Thank you for joining our webinar on anaerobic digestion of roadside grass clippings. As Margherita presented, my name is Marcela Fernandes de Souza. I'm a project manager at Ghent University, and I'm managing the grassification project. And Ghent University is the lead partner in this project. And we also have other 13 partners. They are from Belgium, the Netherlands, and the UK. And they are among research institutes, governmental bodies, and companies. So the main objective of grassification is valorization of roadside grass clippings. And for that, the first question would be, why do we need to mow road verges? So the first reason is for safety. So if we let the grass grow too high in roadside verges, it may pose safety issues for cars. And there is another aspect that sometimes is overlooked, that people are not aware about, is also biodiversity. So when you cut and collect the roadside grass clippings, you leave less nutrients in the soil, which allows for more species of plants to grow. And there are several types of management of roadside verges. So in Belgium and the Netherlands, there is the cut and collect system. So there is this is by law. The municipalities need to not only cut the roadside verges, but also collect the grass clippings. However, in the UK, which is also part of our project region, for now they just have the cut and leave system. But they are studying to change this into cut and collect. So there has been several studies conducted in the UK showing the benefits of collecting the grass clippings for biodiversity purposes. And the whole idea of the grassification project is to transform grass from waste. So current legislation treats roadside grass clippings as a waste, and they need to be disposed of. But in the grassification project, we want to turn it into a resource. So if you have the roadside grass clippings and you put them to different processes, you can actually have several valuable products out of it. And we can stimulate a bioeconomy and a circular economy. And the potential is quite significant. So only in the 2Cs area, which is the area covered by the grassification project, we have 88,000 square kilometers of area, and 2% of these are roadside verges. And this would give 2 million tons of roadside clippings generated every year for processing into products. And the grassification project is looking into the whole value chain. So we have started with the mowing and collecting. We have developed a new mowing head to increase the quality of grass clippings collected from roadside verges. And we also have activities dealing with joint public procurement to be able to improve this collecting and availability of grass clippings. We are looking into different processing options and also different final products. This webinar is mostly related to the processing of the grass clippings. And we have several investigative value chains. So we have biogas production out of grass clippings, we have fertilizer and proteins production, and we have biocomposites and building materials. And as you are aware, this webinar will be focused on the biogas production. And we also have other aspects that we look into these different value chains. So we have technical economic assessments, environmental impact assessments, and a policy roadmap to help guide policymakers to change the status of roadside grass clippings from waste to resource. And in this webinar, we will be also passing through a technical economic assessment and environmental impact assessment, specifically for the anaerobic co-digestion of roadside grass clippings. So thank you very much. If you want to know more about the project, we have a project website. We also have a stakeholders corner. If you subscribe to that, you have access to our project newsletter. And also always feel free to contact me directly for questions related to the project. So thank you very much, and I hope you enjoy our webinar.
Thank you, Marcela, for this interesting presentation. I guess that this can be really inspiring for our audience to start discussing on grassification. And now I would give the floor to Sam Tessens. Sam has a master in bioscience engineering at Ghent University. Since 2017, he works at Biogas E as advisor, and since 2020, he is also coordinator of the Flemish Biogas Association. Sam will be discussing with us the current status of grass AD in Flanders. So, Sam, the floor is yours.
Thank you for the introduction, Margarita. So my name is Sam Tessens. I work for Biogas E, and I will focus on the current status of the anaerobic digestion in Flanders of grass clippings. So just a few words about the organization I work for. So biogas is the knowledge platform for anaerobic digestion in Flanders. Our mission is to actually stimulate the sustainable production of biogas in Flanders. And therefore we focus on 4 main tasks. So the first one is knowledge transfer. We provide free consulting to everyone that actually is looking for information on biogas in Flanders. We also focus on sector development, mostly via research projects. Next, we also provide policy support on everything that is related to anaerobic digestion. And we also try to build a network of biogas professionals in Flanders via our membership. So if you want more information on the Flemish biogas sector, or you want to stay updated on recent developments, I would kindly invite you to follow us on social media, to consult our publication page on our website, or to subscribe to our newsletter. I must say that most of our communication is in Dutch. So before I focus on the anaerobic digestion of grass clippings, I want to say a few words about the general picture of anaerobic digestion in Flanders. So most of the biogas is actually valorized through a CHP on site, producing renewable electricity and renewable heat. And on this graph, you see the renewable electricity production from biogas over the last 15 years. And you can see that actually the last years, this production is stabilizing around 750 gigawatt hours of electricity each year. The light blue line is actually the electricity production from large-scale digesters processing agricultural and industrial waste streams. And I think you can all see that this type of biogas plants is dominant in the biogas sector here in Flanders. We also have limited biomethane production. We have actually one biogas plant that is injecting biomethane into the gas grid. It's located in Merksplas, IOK. It's an organic municipal solid waste digester, and they have a limited injecting capacity. So when we look to grass clippings or the anaerobic digestion of grass clippings, we see some opportunities. From previous studies and projects, we know that the potential is high. And I think Marcella also already mentioned that we have a lot of road verges. We have also the grass clippings from nature conservation areas, from airports, from gardens, etc. So when we look at all the grass clippings that are collected or mowed today, we have an estimated production potential of circa 340 gigawatt hours of biogas each year, and this is around a quarter of the current biogas production. So it has a high potential, and it is really interesting if we can untap this potential. We see that there is also a strong interest from local municipalities in Flanders. Like Marcella also indicated, the municipalities are responsible for the mowing of the roadside verges, but they are also responsible of processing these grass clippings. So for them, the grass clippings are a locally available biomass waste stream, but they're also confronted with a high processing cost. The main valorization or processing method today for the grass clippings is composting, and it's actually a high cost for the municipality to compose all the grass clippings. And they see the anaerobic digestion of grass clippings as an opportunity to actually lower the greenhouse gas balance of the community by using the grass clippings to produce renewable energy, but they see it also as an opportunity to close carbon and nutrient loops on a local level. They can use actually the digestate as a fertilizer for example, public areas or parks. And that's a way to actually implement circular economy on a really local level. But of course, there are some challenges for the anaerobic digestion of grass. And the first one, an important one, is the quality. I think you can all imagine that you have a problem of pollution from litter and sand. And there, adapted mowing techniques and machinery can actually help to limit the pollution of the grass clippings. But there is also a big impact of the grass type and harvesting frequency. You can imagine that the grass type from a nature conservation area is different than the grass type from a public park. In general, the higher the lignocellulosic content, the more difficult it is to digest, the lower the biogas potential. And the grass type and the harvesting frequency have a big impact on this parameter. A fourth point impacting the quality is actually the problem of decomposition. So from the moment you actually harvest your grass clippings, it's really crucial to transport it as quickly as possible to the biogas facility to limit the decomposition rate, to actually limit the loss of biogas potential, because we know that the grass clippings easily decompose quite quickly and lose a lot of biogas potential. So you need an efficient supply chain to actually transport the grass clippings to the biogas plant, or an efficient storage system to actually limit the loss of biogas potential, to actually inhibit the decomposition process. Another challenge that is related to the quality is the storage and pre-treatment. So we're confronted with a harvest that is not continuous. The roadside clippings are harvested once or twice a year, so we have large peaks in the supply of feedstock to the biogas digesters, and the biogas digesters actually need a continuous feedstock supply to run as many hours as possible during the year. So we need to look to solutions to actually shave off these peaks of feedstock supply. And there we can look to storage of grass, so the ensiling of grass, to actually make it possible to store the grass over a longer time without losing a lot of the biogas potential. But also there is an option of co-digesting the grass clippings with other feedstock to actually limit the peaks in the feedstock supply. Then we have the problem, of course, of the rapid loss of biogas potential. So that's something I already discussed in the previous slide, that we have to look to an efficient supply chain, but also an efficient way to store the grass clippings before digesting them. And then we also have the issue of pollution and clogging, pollution from sand or litter, but also clogging. Grass clippings can have actually long fibers that can cause problems in pumping system and stirring systems in the biogas reactor, especially when you're looking to wet digestion. So there you need to invest in pre-treatment to clean the grass clippings, but also to chip the grass clippings to prevent clogging inside the biogas reactor. But of course, this ensiling or this storage of grass and this pre-treatment means extra investment cost, extra operational cost to be able to digest the grass clippings in your biogas reactor. And a third challenge I want to discuss is actually the legislation in Flanders, that is, I think, one of the biggest challenges today to actually have the anaerobic digestion of grass clippings in Flanders. And the legislation in Flanders actually says that it's mandatory to have a post-treatment of the digestate when you use grass clippings in your biogas reactor. So this post-treatment is mandatory because they want to avoid the transfer of plant pathogens and weed seeds from the digestate to other areas when you reuse the digestate as a fertilizer. So that's why the digestate has to be composted for 2 or 4 weeks. It depends a bit on the conditions of your composting facility. So with this legislation, you're actually forced to have a combination of anaerobic digestion and a composting facility. And this means high extra investment costs to actually have a composting floor next to your biogas plant, or high processing costs to actually that you have to pay to process your digestate in an external composting floor. So therefore, the current state of grass clippings anaerobic digestion in Flanders is actually very limited because it's economically unfeasible, mostly because of the combination with the composting facility. And therefore, we only see the use of grass clippings in organic municipal solid waste digesters. Because the legislation for digesting organic municipal waste is the same as for grass clippings. So the digestate of organic municipal solid waste digester also has to be composted for 2 or 4 weeks. So for them, they already have this link of digester and composting facility. For these type of installations, it's quite easy to also take in some grass clippings as part of their feedstock. And actually, this type of digesters use grass clippings as a backup when the input of organic municipal solid waste is rather low. So it's mostly during winter that they sometimes will use grass clippings as a backup to maintain a continuous biogas production over time. So that was actually a brief overview of the current state of grass digestion in Flanders. If you have any questions, you can put them in the Q&A or otherwise contact me later. And I want to make some publicity to end my presentation. So Biogas E is organizing a series of webinars over the coming months, focusing on different aspects of anaerobic digestion in Flanders. So you're also very welcome to join these webinars. These are free. You can find more information on our website. And then I'm at the end of my presentation, Margarita.
Thank you very much, Sam, for this interesting presentation and for discussing accurately the challenges and the opportunities for the grass. I would then, if we have no questions, I would then go to the next speaker. He is Audrey Miseres from Inagro. Audrey is a researcher in team of energy and circular economy at Inagro, and within the Grassification project, she's mainly involved in the valorization of byproducts, innovative crops, and the development of new value chains.
Okay, thank you for the introduction.
Oh, thank you.
Yeah. So I will present you the practical aspects and the way forward of the anaerobic co-digestion of pig manure and roadside grass clippings. It's a pilot plant experiment we performed at Anaerobic. So why? The importance or the potential of roadside grass in co-digestion was just also explained by Sam and Marcella. But as a low-impact biomass resource and unused biomass, additionally a waste product in need of disposal, we see some potential in valorizing that grass, and especially in this experiment, we looked at the co-digestion. Why co-digestion? Because monodigestion is not ideal because of the explained seasonality, the fibrousness, and the peaks. And additionally, we saw opportunity in a co-digestion with vedose manure and pig slurry, for which parameters are not ideal for monodigestion. So could we have a stable digestion process by co-digesting those two input streams, and avoid the number of problems associated with monodigestion of grass? So the test was carried out in the Anaerobic pilot plant, operational since 2007. The installation is a classic continuous stirred tank reactor of 200 cubic meters with a filled volume of approximately 150 cubic meters. It has an electrical power of 31 kilowatts, so it's classified as a pocket digester, and is controlled by Anaerobic in a mesophilic temperature range. The biomass is mixed by a mixer, which is adjustable in width and height. So before the biogas is burned in a combined heat and power units, water vapor and sulfur are removed. And number 1 indicates where the feed liquid fraction of pig slurry is stored. And then number 2, the screw press, is where the grass and the vedose are fed to the digester. So actually, yeah, the process is best compared to the gut of a cow, but I think most of you know the process of the anaerobic digester, in which microorganisms turn the biomass into biogas and digestate. So I will briefly go over the 2 input streams. The roadside grass was harvested in Anaerobic by a flake mower with the adapted mowing head developed in a project. The mowing head adapted by Van Dalen. And the grass was mown in October 2019 and delivered at Anaerobic. Unfortunately, due to longer labor than expected, the grass was delivered in 2 times. And it has impact on the silage process. So in practice, the reactor will need continuous feeds, while the grass is harvested only periodically. So therefore, ensiling is a commonly used conservation method to avoid the anaerobic deterioration. Sorry. And therefore, also at Anaerobic, we ensiled it in a trans silo near the biogas plant. But we had to remove the cover to add the second part of the grass delivered the next day. We observed that the pH was a bit higher than expected after ensiling, and we argue that the ensilage in 2 times is the cause of that. At Anaerobic, the litter removal was done manually, so by hand picking. Then the manure, we used vedose manure. So that's manure which is primarily separated in solid manure and urine in a stable, an adapted stable construction, vedose. And pig slurry. The pig slurry was delivered twice a week, and we added it to adjust the viscosity. So the dry matter content, as we're working with a wet digester and needs dry matter content below 20%. Daily input of 3,000 kilo. You see the percentages in the graph below. 20% was grass, and then 33% vedose, 47% pig slurry. This is an average picture. Actually, we had some variation in the percentage of grass fed to the digester, caused by a little variation of the percentage of grass in the screw press. and variation also in the pig slurry supply and pig slurry feeding. Why complementarity of manure and grass? So on the left-hand y-axis, you see the biogas potential in cubic meters biogas per ton and we indicated it for meadows, pig slurry, and grass. In the light green color, it's the potential which was measured in a lab. The dark one is the one we used in the models, which will be explained later on by Meet and by Vito and Jugend. So we observed a biogas potential of 157 for meadows manure. The lowest one was observed for pig slurry, which is a logical trend, about 33 cubic meters biogas per ton. And grass was around 108 cubic meters biogas per ton, which is approximately the same as the average used in the models. Then methane potential followed the same trends, around 76 for meadows, 10 for pig slurry, and 55 for grass. An ideal CN ratio is situated between 16 and 25 for input materials. Also here we saw complementarity possible for manure and grass because of the lower CN ratios for meadows and pig slurry, and the high ratio for CN was situated around 30. Additionally, this DM content I explained before should stay below 20%. Therefore, the addition of the pig slurry was needed. The grass had a DM content of 31%, the meadows 25%, and so the pig slurry with a DM content of 6% was needed to add. So if we have a look at the results of the BMP tests for meadows, after 24 days, 90% of the maximum biogas potential was reached. While for pig slurry, it took 31 days to reach the 90% of maximal biogas potential. And the grass was much more rapid. So after 7 days only, 90% of the biogas potential was reached. We think also the ensilage process was already preparing the grass for further digestion. Based on these graphs, it shows that longer retention times for the grass are not necessary, but maybe for the meadows and pig slurry. So the experiments run from the 23rd of March till 5th of May, which is quite short. And additionally, we had a defect in the motor from 25th to 9th of April. So unfortunately, it has a consequence on the interpretation also of the results, because this defect in the motor also had a consequence on the availability or the remaining volume of grass which could be used. So we could not prolong the experiment, and we had to stop on the 5th of May. You also see it in the temperature graph. We still stayed in the mesophilic range, but due to the problems, the temperature strongly decreased, and it took a while to increase again. If we look at the biogas production during the experiment, so we start from 9th of April, because the data before, you see it with the first dot, which is under the 3, are not representative, because it went to 0. So with some careful interpretation, we see the biogas production was stable and situated around 8 cubic meters per hour. And if we compare it to an experiment conducted by Pocket Power last year, we observed the same results. In Pocket Power, it was a monodigestion of meadows and pig slurry, so the same experiment but without the cross. So here we see that the cross did not have a negative impact on the biogas production. If we have a look at the daily electricity production obtained during the pilot trial, we see that from the 9th of April, the production increased, which is a logical trend due to the problems till 8th of April. And stable values, or more or less stable values, were obtained quite late, only from the 19th of April. And unfortunately, we cannot observe how it evaluates later on. But from 19th to 5th of May, a plateau around 200-250 kilowatt hours was reached. If we look at gas composition, based on the methane content here, we also observe the same trend. The expected methane contents for mesophilic digestions are situated between 55 and 58%, and this percentage was reached once the system had stabilized. It's compared to the Pocket Power experiments with monodigestion of meadows and pig slurry. This was much more stable, but is it related to the input materials? That's still a hypothesis, but we are not sure. We are not sure the cross is influencing this stabilization. And then if we look at the products next to the biogas of the digestion, so the digestates, there was still some, the pH remained stable, but there was still some remaining potential in the biogas, in the digestates, situated around 39 cubic meters biogas per ton, showing that the retention time should be longer to obtain a bigger gas production. This is maybe in contradiction to what I said before, related to the cross, but we observed the same results also in the experiments in Pocket Power, showing that for meadows and pig slurry, especially with the second restart of the whole process, the retention time should be longer, and a longer experiment is needed to observe what it would do to the potential of the digestate. This is also reflected in the CN contents of the digestates. We would expect that even more carbon would be decomposed and more nitrogen would be mineralized. But if we can conclude, it seems, if we are very careful based on the results, that it's technically feasible to digest the cross. It's not a surprise because it was already done also. There was already a co-digestion experiment done a few years before in a TransBio project, but it was not performed in a pilot plant. It was only in the lab. But as Sam already mentioned, there are still some bottlenecks. These are litter, sand, and legislation mainly. I refer to the following presentations also, where the possible pre-treatment costs and environmental impacts are taken into account in the different models. There are some possibilities, but of course it has impact on costs and investments. So it's a bit yeah, we have to see if those bottlenecks can be solved, and if it's solved, yeah, then we think it's still technically feasible. But without solving those bottlenecks within acceptable costs, it might still be, yeah, as Sam said, still be difficult to digest the grass, especially roadside grass, in wet digestions. There's maybe more future for dry digestion of roadside grass. Okay, thank you for your interest in the project. And then I hope also with the additional models, we can show you the whole possible value chain of digesting this roadside grass.
Thank you very much. Actually, we are already receiving some questions for you, so I would take at least one of these and address it right now. So Rick Boiting is asking if adding urine to the digester gives problems with ammonia.
No, we had no problems with the addition. I don't have the numbers here, but I can refer you to the report, which is also available on the Grassification website. But we didn't have problems with the ammonia content.
So I would say that for now it's fine, and we can maybe move forward with the next speaker, and we will address the other coming questions in the Q&A session.
Yeah.
So thank you again, Audrey.
Thank you.
And I will then introduce Miet Vandel. She is working at Vito as expert in techno-economic assessment in the field of bio-based economy, and within the Grassification project, Vito is responsible for the economic assessment of three cases: the landfill digestion, the agriculture digestion, and the biocomposite case. Miet, the floor is yours.
Thanks, Margarita, for the kind introduction. As said during this presentation, I will focus on the techno-economic assessments, but I will mainly focus on like the different bottlenecks that were mentioned by the previous speakers, what the consequence is. We will write a report with all the detailed numbers and assumptions behind it. This will be a public one, so you can read it afterwards. And in the presentation today, I will mainly put some reference values which we will use, but I did not add the results yet of the techno-economic assessment itself, as this will be available very soon. So the main bottlenecks that needs to be taken into account that might have an economic consequence is, of course, the seasonality of the grass, the scent and the litter that is present in the roadside grass. There are also some small effects in the digester itself, which I will mention. And then the biggest challenge is, of course, the post-treatment of the digestates. In the next slides, I will give more details about each of these. So the first one was already mentioned. It's the mowing season that we have from a legal perspective. This poses seasonality. Of course, there is a perfect solution for this, as we can just invest in a trench silo. This was also done at Anaerobic. The cost for this are about 40 euro per cubic meter. So one of 600 cubic meters is around 25,000 euros. If you fully make use of this capacity, then taking into account the density of the grass, etc., will be around 7 euros per ton of roadside grass, which you store. Of course, if you also need to invest in like access roads or some drains, this cost might be a bit higher. So the cost that I present here is an indicative value for the trench trench silo itself. Another thing that needs to be taken into account are the logistic challenges. These were also mentioned by the previous speakers. One has to take into account that mowing the grass also takes time. You have to bring it to the trench silo itself and within a reasonable time. So there are my colleagues, they will use the move tool to also check what are possibilities there, whether some kind of in-between storage is needed, or whether we use multiple mowers or maybe multiple silos, smaller size then, but to make sure that the quality of the ensiled grass is really appropriate for the anaerobic digestion. So that's really important. Then another bottleneck that was mentioned is that sand is present in the roadside grass. The impact on the digestion itself, it's expected that this will be limited. So the main influence is on the available reactor volume. There are some potential solutions we thought of, like washing the grass beforehand, but it is not a guarantee that all the sand will be removed. And also, like, we will use a lot of water for it, and there is already some pressure on the water availability. So my personal opinion is that that is not the best way to go. In the Pocket Power project, which was also already mentioned, they also looked at whether the reactor design itself can be changed, like a ground scraper, for example. But like these additional investments, they are quite expensive, and actually, if you see at the impact that the sand has on the reactor, it's not worth the money. So it's better to say after a couple of years we just clean the reactor and then continue to use it. And of course, the best way to avoid it is to avoid it already from the beginning, and therefore the adapted mowing head that was developed within the Grassification project is probably the best step that we can take for this bottleneck. Then another thing that needs to be taken into account is the presence of litter. So we really focused on pocket digestion, so small scale digestion with a stirred system. So there's a mixer inside, and therefore some pre-treatment is needed. As already mentioned, at the Anaerobic, handpicking was done now to remove the litter. On the pictures, you also see what they found in the roadside grass. Of course, the farmer, he wants to use his time for other things than removing litter from the roadside grass. There are some potential technical solutions like a magnetic separator, a shredder, or a sieve, but also previous experiments have shown that, for example, the sieve, like the efficiency is not that high. Around 1/3 of the grass ends up in the wrong bin to remove it and not to use it in the digester itself. So there are some technologies that can be used, but they are certainly not perfect yet. Also, a wind shifter, for example, was taken a look at, but you can already imagine where the grass ends up. So not in the right bin, unfortunately. So that is something that one have, where some technologies might give some solutions in the future. But I think at this moment, the mowing contractor is your best partner. They often know quite well where there's a lot of litter. For example, in the neighborhood of the McDonald's, you don't want to be. There's a lot of litter. So I think the mowing contractor can really be of help for the litter. Then in the pocket digester itself, so Audrey also mentioned, and also some mentioned, there is a possibility or a potential for grass to be digested. That's technically feasible. That's no problem. It might even have a potential positive impact, although some additional research might be needed to really prove that. But the biogas potential, it's not bad. Also, if you look at the graph, we took in our models a value of 110 cubic meter per ton as a starting value. If you look at the literature, the ranges are quite broad. But in our model, we did not take into account the fact that there is a difference between spring or autumn cuttings, or whether or not the grass is ensiled beforehand, because in our model we assume that part of the grass is directly fed into the reactor and part of it is ensiled. But we do a sensitivity analysis to see what the impact is of the biogas potential exactly on the economic feasibility. Also, the gate fee. Prices are quite broad. I've put a range here from 25 to 35 euros per ton. Sometimes you also hear 40 euros per ton. But you have to take into account that, of course, this gate fee also needs to compensate for all the additional costs that you have, like the litter removal or also the post-treatment afterwards. One thing that you should take into account is that if you add the roadside grass into the pocket digester, that the own consumption of electricity is higher, because you really need to mix more to avoid also floating layers. So we assumed in our models that 25% of the electricity that is produced, that is needed for the digester itself. Then the most important bottleneck with an economic consequence is the post-treatment of the roadside grass. So currently, often there is a separation between the thin and the thick fraction. The thick fraction is about 50% of the digest state. This is often done with a centrifuge or a screw press, for example. And we take into account the cost for a mobile installation, because we look at small scale digesters, and then often renting a mobile installation is cheaper than really investing in an installation yourself. For the tin fraction, we take a disposal cost into account of 4 to 14 euro per ton. It depends a little bit on whether you can bring the tin fraction to a field, or that you have to further process or let it process by a manure processor. And for the thick fraction, we take into account a disposal cost of 20 to 30 euros per ton. Of course, if you have to export the thick fraction, then there is hygienization rules that you have to meet. It's that it's 1 hour at 70 degrees Celsius, the step, and often a biothermal drying or a thermal drying is used. And we also give an indication of the cost for a trommel composting, for example, but it can also be a bigger hull where one treats the thick fraction, and then we rather take into account this disposal cost, which is mentioned above. But if you add the roadside grass into the digester, then this rule changes. Like mentioned before, then this hygienization of 1 hour at 70 degrees is insufficient, because we cannot guarantee that all weed seeds and plant pathogens are eliminated. And so there are additional rules provided by OVAM, and it's stated that the digest state needs to be composted in its entirety. So that is already a big impact, because in the previous case, you only had the thick fraction, which is further hygienized, whereas now the digest state in its entirety needs to be treated. So if you take a cost per euro of a cost in euro per ton into account, you already see what the impact of this will be. It's also according to the rules for organic municipal solid waste composting. So you need a hull or a tunnel composting. And as we work on mesophilic conditions, it's a composting of 4 weeks that one needs to take into account. And there are, of course, some rules for the minimum temperature that needs to be met. Of course, if you have this post-treatment that you have to do, then this impacts the process that is used by the manure processor. One of the impacts is that he might already have this facility, but now it's for 4 weeks that he has to compose the digest state. So of course, if you use this capacity for a longer time for the same feedstock, then this cost will increase. Just as a reference value for organic municipal solid waste composting, the typical gate fees are around 35 euros per ton. Also, the manure processor, if he takes roadside grass as a feedstock, he needs to have a permit as a waste processor. I don't see that as a big problem, as they already make use of organic biological waste as a feedstock. So I don't think this will pose or this will have a big impact. And of course, if you do not take only the thick fraction, but the full digest state with the dry matter content below 14%, then this means that also structure material needs to be added, and this will also impact the costs. So my message is basically the same as what the previous presenter said. From a technical point of view, it's perfectly possible to digest grass. It's even with the biogas potential taken into account, an interesting source. But if you look at small-scale digestion, that is the pocket digester, then there are some serious points of attention that we have to take into account. The ensiling and the pretreatments that need to be done beforehand. There are solutions, but it brings some costs with it. And the biggest impact, of course, these specific requirements for the digestate treatments that really will influence the costs. And therefore, we think that currently, dry organic municipal solid waste digestion is probably more likely as the first place where you want to bring your roadside grass to, as they just have many of these facilities that you need for processing the roadside grass already available. Like they already have pretreatment installations, and they have the composting facilities already at their disposal. So probably dry organic municipal solid waste digestion is a more likely option. Also, the pretreatment for litter removal is less of an issue there, as they don't have a mixed system. So these are things that one needs to take into account. As mentioned, I mainly focused on like where you can expect the economic impacts. I did not provide yet the detailed results, but the report will be available soon, and there you have an overview of all the different assumptions that we have taken into account, like the investment costs, or also in there all the technical parameters that we take into account. And if you have any questions about that after reading the report, you can contact me. I provide my contact details here, and the slides will be shared afterwards. So don't hesitate to ask questions about it. And then I look forward to the next presentation, where we also have a look at the environmental impacts.
Thank you, Miet. Actually, we do have already one question for you that maybe we can address right now, and it's from Adre Viken, asking, are the additional investment costs to build the trench silo?
Yeah, so the costs that I've mentioned is 40 euro per cubic meter, or for one of 600 cubic meters, or 25,000 euros to build a new trench silo.
Okay, so thank you so much, Miet, for your presentation, and I guess that we will address some more questions in the Q&A session.
Okay, thank you.
Right now, I would give the floor to Rahul Ravi. Rahul is a joint PhD student from Ghent University and University of Copenhagen. His research interests revolve around the life cycle assessment of bio-based value chains, and in the Grassification project, he is primarily involved in assessing the environmental impacts of the value chain. So, Rahul, the floor is yours.
Yes. Thanks for the introduction, Margarita. I hope you can see my slides.
Yes.
Okay, perfect. All right, good morning, everyone. My name is Rahul, and today I'd like to talk about life cycle assessment of roadside grass verges. The previous speakers spoke about the technical feasibility of co-digesting grass as well as the economics, but this session would primarily focus on the environmental impacts. So According to legislation, what Flanders says is, roadside grass must be harvested, collected, and effectively managed. And according to the Verge decree, they say roadside grass should ideally be composted. Although we do see some municipal operators just cutting the grass and leaving it as piles along the sides of the roads. So yeah, we consider an ideal case scenario, which is composting, and that is basically my baseline case. And like the theme of the day, the alternative is to see whether or not it makes sense to co-digest grass with manure. So people who are familiar with LCAs would have often listened to these terms, attributional and consequential. This is a big matter of contention in the LCA fraternity, and just quickly explain how these two approaches are modeled. So let's consider this pie to be the anaerobic digestion sector in Flanders. And typically, if you want to study the impacts of co-digesting grass with manure, so you basically just cut a chunk of this pie and measure the environmental impact. So you're applying sort of a normative rule, and you just look at average data and say, okay, I throw in grass with manure, this is my environmental impact. Consequential, however, is a slightly different story. Here, you're basically modeling the changes in your system, which is to basically capture the consequences. And as the figure illustrates, you can see this shaded portion. So what are the consequences if I bring grass into the anaerobic digestion market, and how is it going to change? So typically with consequential LCA, that is what we're using for our study. You have to look at the market data, and you also have to work with marginal suppliers. So that's what I did. I looked at the anaerobic digestion market in Flanders. Sam was kind enough to share some information as to the market mix. And you can see it's predominantly bio-waste, which is around 63%. And the remaining is around 27% of manure and some energy crops. Manure, it's a no-brainer because animal husbandry is quite the thing in Flanders. And since you have a lot of pigs, you need to stabilize the manure. Also we did speak a lot about pocket digesters, and that's what also Inagro is implementing. So around 50 out of 55 pocket digesters or small scale digesters use fresh manure from their own farm. And it's also important to note that bio-waste, it mostly includes food waste, which is basically from domestic catering, retail, and also from food waste industries. What happens if you bring grass into the mix? So this is the ideal scenario. Like I said, animal husbandry is quite a big deal in Flanders. So you have a lot of these farms trying to digest, valorize the manure before stabilizing it. And it is typically digested, and you have some useful electricity out of it. So, some of it is used within the installation and some is fed to the grid. And you also have a lot of research going into how the digestate can be valorized. One problem with monodigestion, as Audrey pointed out, is pig manure is rich in nitrogen, so it sort of induces risk of ammonia inhibition. And also the pig diet contains sulfur compounds, so this could mess up with your anaerobic digestion, and also we have problems with foaming. So what is typically done is co-digestion is followed, as the speakers again were pointing out. And if you look at the market, ideally food waste, since it's sort of rich in carbon, is co-digested with manure. So since we're doing a consequential sort of LCA, we're saying, okay, if we remove food waste and we throw in grass, what exactly happens with the food waste? So you have to capture the consequences in your system. So you also have to look at alternative food waste management. So just diving a little bit deeper into what really is happening with the food waste here. This is the food waste cascade, the reverse sort of pyramid, and which basically looks into the triple R approach. So the first case is to prevent your food waste, next is to valorize, and finally is to remove or destroy the food waste. So typically these three layers have already been satisfied. So whatever is not, if you're not able to prevent, or if you're not able to give it to animal feed, you're looking at valorization, and this is what is currently happening. You can see that according to this OVAM report, more than 50% of the feed of the food waste after animal feed is either put through anaerobic digestion or composting. and around 11% is well raised for its energy. So basically, if you remove grass, then you have to look at what happens with the food waste. And yeah, the ideal case would be is to basically incinerate the food waste. So that is the next order of preference. So the key assumptions, keeping in mind all these aspects, is that I've considered roadside grass as a material for treatment. And by material for treatment, I mean that roadside grass is not a determining product for any activity. So let's just, for example's sake, assume that you have a digester which solely depends on grass for its biogas production and using that electricity to feed the grid. So it's not happening right now. It's just roadside grass is seen as a waste and it has to be managed, and hence it's a material for treatment. And I also assume that it is added as a co-feedstock to balance the C/N ratio. So the prerogative of a farmer is just to make sure his system doesn't crash, and that's why he's adding grass into the system. And yeah, there are principles of consequential LCA, there are guidelines, and it speaks about how you have to model material for treatment, and you have to see whether or not it is fully utilized or if it is partially utilized. I sort of assume that the material, the grass is like fully utilized within your digester, and it's ideally seen as a recycling activity. So grass is a determining product for your sort of digester to function, for your co-digestion process to function. And since consequential LCAs depend a lot on market information, you also have to look at the marginal technologies. And also, yeah, it's important to look at the biogas market. So Sam did show us a graph earlier about the electricity trend over the last few years. And we can see that the market sort of, I wouldn't say increasing, showing an increasing trend. It's sort of showing a stable trend. It's neither decreasing nor increasing. And you can model different scenarios. So what I considered is two scenarios. I'm considering if the biogas market is increasing, and also I'm also looking at the general market volume decrease. So this graph sort of shows capital, the technology over time. And if you consider a biogas plant and if it has a lifetime of 30 years, so the capital replacement rate would sort of decline at 3.33% annually. So anything above, if the market trend is above this line, then you typically say the modern technology is your marginal provider, which basically means anaerobic digestion according to the food waste cascade. And something which is below this line means the older technology or the least competitive technologies sort of affected. So basically, with an increasing market, I would say the food waste would probably be digested. And if it is showing like a general decrease, or if it is along this line, then I would say the food waste is incinerated based on the cascade. So looking at all these assumptions, I've sort of drafted my scenarios. You have a baseline, which is basically composting. You have one ton of roadside grass is mowed grass is my functional unit. And it is basically brought through the composting process after ensilage. And you have some useful, I'm sorry, there's no ensilage here. Beg your pardon. So composting, it's just roadside grass is brought in and composted, and you have compost which sort of has a certain NPK content, and it avoids conventional synthetic fertilizer. And you also have some structural material, as Meet mentioned, and we assume that the structural material brought into the composting process is burden free. And also you have some auxiliaries coming into the composting process like electricity and water and so on and so forth. So another scenario, if you assume that the biogas market shows an increasing trend, then what would happen is that, again, my functional unit here is 1 ton of mowed grass, and you have the ensilage, what is happening before it is being co-digested. Like Audrey mentioned, Vidus and raw pig manure is also brought into our digester, and you have useful products, which is basically biogas and digestate. Some of the biogas, some of the electricity from the CHP is used for internal is for internal usage, and some of it is fed to the grid. And also the digestate, as Meet mentioned, it has to be managed. So what I assume is that it's transported to a composting facility where it is composted with other structural material, and you also have some useful, you have some fertilizer which is basically avoided in the market. And so if you throw in grass into your digester, it's sort of, you also have to model the consequences of what happens with the food waste. So what I've considered here is that the food waste is basically put through anaerobic digestion again, which basically means other digesters have the capacity to take up this food waste. Another scenario is looking at sort of like a stable trend, or maybe even a decreasing trend. So you have similarly, the functional unit is 1 ton of mowed grass. You bring it in, and the same process happens. However, here the food waste is assumed to be sort of incinerated. So you have 3 scenarios, which is basically composting and alternative food waste management in the form of anaerobic digestion and incineration. So the impacts, it's actually a no-brainer. Previous studies clearly showed that it is not a good idea to, I mean, if you compare composting versus anaerobic digestion of roadside grass, then anaerobic digestion performs better. You can see that scenarios 2A is better off than 2B. 2A is where you assume your food waste is anaerobically digested, and here, it's with regard to incineration. Again, these are preliminary results. I still have to look into uncertainty and sensitivity analysis of different criteria that Meet mentioned. And it shows a similar trend for other impact categories as well, like human toxicity as well as terrestrial acidification. And I've just shown a contribution analysis of the carbon footprint of the entire process. And you can see that for composting, it's predominantly the composting process itself. You have some carbon dioxide emissions as well as other, methane as well. And with regard to scenarios 2A and 2B, you can see that there's a lot of savings with regard to anaerobic digestion, because you have some electricity from your CHP and it is fed to the grid. And there is also some, these impacts basically concern the post-treatment of the digestate. And so basically 2A is better off, where you assume that your food waste is anaerobically digested. And so that's it. That's the conclusion from the life cycle assessment. Of course, there are other scenarios where you can explore for your grass value chains, such as looking into the fiber valorization and also monodigestion of grass. So today I've just focused on co-digestion, and overall it shows environmental benefits relative to the baseline case. And also the net savings, it depends whether or not your grass is like seen as a waste, or if it's like a really important feedstock for your anaerobic digestion. You have to see if it's demand or supply driven, and it also depends on the current status of the biogas market. And also we are in a discussion to create a hybrid techno-economic assessment and LCA assessment model to further understand trade-offs, because sometimes the LCA models sort of say it's really good idea to do this, but it has to work out economics wise. So you sort of use a multi-criteria decision tool to weigh in the results from both the models to come up with like a useful sort of solution for the policymakers. So that's it from me, and I'd be happy to answer some of your questions.
Thank you, Raul, for your accurate presentation. As you said, we will leave the questions in few minutes. We will address them in few minutes, and I will now leave the floor to Henry Daimoc, who is our last speaker of today, and he has a foundation degree in farming and environment at Lincoln University and a degree in environmental biology at Reading University. He is working in a farm and with ID plants, and he's also involved in renewable projects. Henry, the floor is yours.
Hello, can you all hear me and see this all right? So I've got an anaerobic digester on our farm here, and we've been feeding roadside grass in for about 3 years now. Very quick overview of my plant. So there's 4 tanks to the plant. We have those 2 smaller round concrete domes at the front are hydrolysis tanks. So they're our pre-treatment tanks that then lead on to the other 2 tanks. It's a 499 kilowatt AD plant, obviously produces as much heat as electricity. Our main feedstocks are chicken litter, maize, grass, because we've got sheep here, so sometimes it's an early cut off our grass fields or it's the roadside grass. And then we quite often use whole crop energy crops such as barley or triticale. And we've certainly done cattle manure as well from a neighbouring farmer. We've done things like veg waste in the past. We've done all sorts of different feedstocks, but generally they're a bit unreliable, and AD plants generally want a very stable and set temperature to run well. So we've got a 2-stage process. First 2 tanks are hydrolysis tanks. So we run those at around 55 degrees. It's in there in each tank for 12 hours. It's then from the second hydrolysis tank into our 3rd main digester tank, which runs at 43 degrees. And it's in there for about 35 to 40 days. And then the 4th tank, which is our largest one, is more of a storage tank. But again, we do produce about 15% of our methane from the leftover stuff in that tank. It's from that tank that we then separate out the solids and the liquid, both at the moment, which go back onto the farm as a fertilizer. And then we use the heat for log and wood chip drying, as well as it heats the office and a couple of local houses. Currently, most road verges in the UK are just flailed and the grass is just left on their side to rot, which obviously denies the bees and butterflies from other sources of flowers, which doesn't really help with the food chain. In Lincolnshire, we do have a series of roadside nature reserves. It kind of links some of our triple SIs and other areas of outstanding natural beauty together, so it is important that we look after our roadside verges. And at the moment, just the cutting and leaving it is we've lost something like 6 different species of flower species in Lincolnshire because of the way we currently manage our roadside verges. So the projects I've done are with local council as well as the local wildlife trust, and together we have made quite a big difference on our road verges, albeit the whole process will take about 10 to 15 years before you see any real significant difference. So here we have on the left is one that we mowed recently, and as you can see, the grass where we've cut it, it's very brown, it's decaying, it's releasing methane into the environment just while it's rotting down anyway. But also, as you can see, it's just full of grass and all that white flowers, cow parsley. That's all we have. There's no real nature biodiversity to it whatsoever. Whereas the one on the picture on the right is something that the Lincolnshire Wildlife Trust have been managing themselves. They've been cutting it and collecting the grass. That's not, as in, it's literally a guy with a scythe and a rake. That's not realistic to do on a large scale. But you can see there's a lot more wildlife in that, a much bigger biodiversity. So we do need to cut it and collect it, not just cut it and leave it to manage our roadside verges. The Linear Infrastructure Network, it's a UK-based organisation, has suggested that there's basically around 1 million tonnes of grass available if we just did, roughly half of our roads and half of our rail network. It's the area of one of our counties, basically. It's a massive volume of grass that is available. And we shouldn't really just be leaving it on the sides of our roads to rot down, because it's damaging to the environment because of the gases it releases, as well as the suppression of flowers. So our venture involved, I did it with 2 other neighbouring AD operators. We ran the project together. We built our own machine and owned the machine. Economically, we tend to do it in a 10-kilometer radius of each site. It's not worth hauling this grass miles and miles. It's, you know, we can harvest it in a 10-kilometer radius for about £20 per hour of the to run the machine, the harvester itself. Well, it's worth about £30 to an AD plant, so it is worth doing. But if you're moving it a long way, it is only just grass. Albeit it makes a big difference depending on what you're actually running it with. So it works well with maize, because maize can be quite high, and the chicken litter, because they can both be quite high in nitrogen, whereas the grass is quite high in carbon. So it does balance the carbon to nitrogen ratio in your tanks. Now you can get a big difference in yields between years. So our 2016 year was pretty not too bad, but it was been a really wet year and it was a cold April, so the grass just hadn't grown by the time we started, because the other thing, we're bound by the council rules of when we cut, for safety reasons, of when we start cutting. And because obviously we're farmers, well, we harvest the wheat when it's ready. We don't go earlier, we don't go later, we harvest it when it's ready. Well, ideally you'd be doing that with your road verges, harvesting when it's right, but at the moment we have to harvest when the council tell us. So the grass can vary quite a lot in its just sheer volume, which doesn't help that much to having a stable AD plant. So Leeds University ran a simple lab test for me. The difference between, so that green line is the grass, how much gas was produced by the grass. The yellow line is how much gas was produced by the maize. So there is a very definite good gas potential to it, and equally in practice, when I put it in, it does work well. I think we'd struggle to run a system just on grass, and equally we don't do as well running a system just on maize. They definitely complement each other. So it's worth running with grass with something else, such as manure. The other guys have been talking about. We use chicken litter because there's quite a lot around here. We don't have that much livestock in Lincolnshire. We are predominantly an arable county. Fresh weight and biogas yields indicate that verge biomass can constitute a viable feedstock for AD plants if it is harvested reasonably close to your site. So like I said, it was costing us sort of £20 to run the machine per hour around the AD plant. But for the volume of grass it was bringing in, it is worth it, and it does work. I mean, one of the things where we're situated, they're quite small roads. We have run a project on the M180, which is a big motorway. I suggest it because of the litter content, not worth doing it on big motorways. There's no two ways about it. We had to collect the litter beforehand before we could cut it there. Whereas around us, okay, there is a bit of litter, but it's not horrendous. A lot of it is McDonald's stuff chucked out of windows. A lot of that, the rubbish itself, is paper and cardboard, which isn't the end of the world to an AD plant. Things like plastic lids, not that great and will come out in the digestate. But depending on the type of AD plant you've got, it'll just smash it up to nothing anyway. It's not, as long as it's at low levels, it doesn't matter going onto the fields to use as a fertilizer. So the machine on the left is the one that we've designed and built ourselves. It's just wraparound on the tractor we've got to reduce costs. We run it with 2 trailers, so the machine can carry on cutting. It doesn't have to come back to site each time. I'd send one of my guys out with an empty trailer, they'd switch trailers and he'd bring back the full trailer, which made it a lot more cost effective. It's basically, the longer he could keep cutting, rather than having to stop. If he spent half his time coming back to site to tip the grass, it's not so economically viable. The machine on the right is all singing and all dancing. I had a go on it. It is a wonderful machine, but at 300,000, yeah, not worth it. It didn't really have the ability to drop a trailer off. It can, but it's very complicated. You'll lose half an hour just trying to change trailers. Not worth it. And that's the kind of machine. It's a Belgian machine, and fair enough, it is a very good machine. It's got all kinds of lasers and sensors on it. Works beautifully, but yeah, 300,000, not worth it. my wraparound tractor one with 2 trailers we did for 70,000. It's a very different cost, and also means, you know, I can use a tractor and trailer for other things throughout the year. That machine can only harvest grass. Well, for 10 kilometers around an AD plant, we might do 3 cuts a year. It's perhaps only doing 6 weeks work. I don't need to spend 300,000 on a machine that's only doing 3 weeks work for us. It's not worth it. So a lot of it does come down to economy of scales. As far as here in the UK, the biggest problem is PTEs and PAHs. It's down to the things like heavy metals, the polycyclic aromatic hydrocarbon levels. It's what the Environment Agency are worried about. So again, we've done a lot of tests on that. It's nothing any more than what we find in our maize silage or in our whole crop silage anyway. So despite all their wittering, there's very little there. Again, this has all been done on smaller back roads around the AD plants, not off the M180, albeit we didn't find anything too serious actually in the M180, so it wasn't too bad. There's various ways of storing and collecting it. So here, this was our M180 test. We baled it because then we could check each site. That's why it's labelled. So we could get an analysis of each one. But that's baling. It's a very expensive way of doing it, and I suggest it's not worth it. This is just from the M180. It's different. There wasn't that much grass in your first cut. There isn't that big a volume anyway on the motorways. A lot of it just comes down to when they repair the roads, it's the chemicals they use to do it. It's not really that great for the grass growing anyway, and it's quite often very dry because obviously they've got to make sure they're not flooding a motorway, so it is quite important. So the grass, you know, again on big motorways, I suspect that it's not really worth doing for an AD plant, mostly because of the litter content. You know, there is a lot of litter to sort out from blown out tyres and that kind of thing before you can even start cutting, and there's a cost to getting rid of that as a waste. So this is us doing it at my AD plant. So it's just there on the right by the teleporter. That is mown grass. You can feed it in fresh. I do it. It's not a problem. You couldn't feed lots in because it will cause an AD plant to foam. But generally, and then that bigger, darker heap is where we've ensiled it. That was last year's, which we ensiled. It lasts well. Ensile it properly in a big clamp, and it does last, and it does work very well. It acted much like our normal pastureland grass. So just the general commonalities between the two projects, so the one we do round us and the big M180 project. Composition of the biomass was similar. You know, the grass is a low input, unimproved permanent pasture land, typified by the invasion of vigorous herbish species. So, you know, part of the problems in the smaller roads around us is hedges growing out because they're no longer managed by the council. Or once in a blue moon, they might come and cut them, but basically councils can't afford to manage roads as well as they used to. Optimum yields of verge biomass definitely suitable for AD plant, but you want the earlier cuts, so the April, August cuts. I wouldn't want a cut for an AD plant after August. It's a lot more like hay. It is hay basically. It's dry, it's stringy. It does nothing but float in your tanks. It's definitely, you know, if you know much about grass produces glucose as an antifreeze early on, so your early April cut especially. In the UK here, we're still getting a few frosts. It is very rich in glucose, the grass. It is definitely worth putting in an AD plant. By, you know, August and afterwards, it's hay. It's not really worth going through an AD plant unless you've got some very expensive kit to really chop it up, really, you know, break it down with thermochemical conversions. But the later cut isn't worth it for an AD plant. Harvest yields can vary a lot, and it doesn't matter whether it's on the M180 road or the little roads around us. You know, the April cut, some years can be very dry, some years very wet. Some years the grass is really growing like there's no tomorrow. Other years you wonder what month you're in because it still hasn't started growing. And April's when, according to the councils, we have to do a cut, whether there's grass there or not. But that's just slightly bizarre UK ruling. It's definitely suited for plants that routinely feed energy crops, grass or straw-based materials anyway, because generally, so we've got a thing called a rotor cut on site. It smashes whatever we feed into sort of 3 mil length stuff, which means there's a much bigger surface area for the bacteria to work on. It's a lot easier that way. Again, the verge biomass, like anything, we have to ensile it, and delittering, we personally don't. For our local roads, it's not that bad. There's a bit of, sand in there, but we routinely clean out our first tank anyway, because there's no more sand coming out of the roadside grass than does in our maize silage anyway, that we just pick up in the fields. So we routinely, once a year, turn off our first tank, dig out all the soil. We get about 40 tons out a year, and it means it keeps the rest of the other 3 tanks clean. So it works quite well for us anyway. And then, so floating layers are a problem playing with anything like straw or grass. But, the early cuts, they tend to be wetter. They're not so bad as long as you chop them to a nice small chop length. By the time you're getting to your later season, sort of end of August, September, where it's more like hay, it doesn't matter how small you chop it, it will float. The Aon harvest site on the M180, again, you see it required a pre-litter picking. For the test, we did it by hand. There are machines out there that can just go along. They look a lot like the machines we're using to cut the grass with, and they will just basically suck up all the litter. But there's a cost to then getting rid of the litter, so it's suspect that M roads are not worth it. I mean, where we are in Lincolnshire, it's not a problem. The M180 is nearly 2 hours away from where we live, and that is our nearest motorway. So in rural parts of the world, smaller back roads, it's definitely worth doing. If you're doing, we've got a trial next year around the M25. It's not to go into an AD plant. It's with the litter and the pollutants that are in there are horrendous. It's it's for a different project. And again, PTEs and PAHs from both were surprisingly low, actually, and they don't breach any of the safety guidelines, especially in terms of then putting the digestate back onto the land afterwards. And then here in the UK, our Environment Agency are the biggest problem, because you have to have a waste license code on everything. They don't really want to give it a one, so they don't even know where to start. Then coming out at the other end, so the solid and liquid digestate out the other end, they want us to pay for the privilege of spreading it onto our own fields. Again, you have to put a code on it. They can't quite manage that once the grass has gone in. It fits under a couple of different codes under the waste hierarchy scheme, but they don't really want to tell us which one. So they're a bit like trying to get blood out of a stone doing anything with the EA when it comes to doing something new in this country, which is a shame, but that's how it goes. So that's it. If you have any questions, do let me know. Thanks.
Thank you, Harry, for your presentation. I guess that now we can open the Q&A session, and I would then give the lead to Marcela Fernandez de Souza, and I would ask all the speakers to turn on their cameras, please.
Okay. Thank you, Margherita. So just building on the presentation from Harry, Martin Ward, which actually works with us in Grassification, he made a comment in the chat, which is important. So he says there is a requirement within Highways England to litter pick before the grass is cut on motorways. And they are under increasing scrutiny to ensure it's completed, so this barrier to working on motorways should be removed. But I do guess this would give more costs, together with
so the M180, but they don't pick it early enough for us. We want an earlier cut of the grass, because the grass is much higher in glucose earlier on. They want to go pick the rubbish, say, mid-June. By then, I want to have done 2 cuts. So it's not that helpful to me. I'm still going to, in effect, have to go collect the litter, whether they're supposed to be doing it or not. If they don't do it early enough, it doesn't help us at all.
Okay.
Yeah, hi Henry. Sorry to interrupt. The area you're working with is a different contract model, which I believe is switching to asset delivery later this year.
Right.
We have a completely different contract framework with our supply chain, and the requirement there is to collect litter before every grass cut. So we're in a situation where the grass is going to be cut and it's going to be litter picked. So I think we just need to try and tie them loops up, because the work is going to be done and we're missing the trick in not collecting it. Obviously, it always comes back to the issue with the EA, but just wanted to let you know that barrier is potentially going to be removed for you in the future. So don't give up on the MOs just yet.
No, we're not, because I look after about 30 sites around sort of Lincolnshire, North Yorkshire and Derbyshire. I don't know why, because I'm just a local farmer, but they keep phoning me for help. And so I've got plenty of sites that are interested in this project. They just need me to do it all for them. But that's fine.
Okay, but but maybe just continuing, how this impacts the costs, because I assume already cutting and collecting is already a huge cost for municipalities and councils, and if you have to litter pick beforehand, it would I would assume it would only worsen the situation.
Yeah, so I work with the Lincolnshire County Council, and they don't litter pick, so the M180 isn't part of their problem. And they'd be horrified about them having to litter pick. They'd want us to do the litter pick first. But again, you see the machine we've designed. See, the M180 is slightly different. By the time you've got massive, big tyres blown out, it would struggle with that. But for the rubbish we find, beer cans, McDonald's wrappings, a few bottles, we can literally suck it up at a fairly cheap price. It's the cost of then actually getting rid of it. So a lot of the rubbish has to go to landfill, which at the moment is a horrendous cost. And that's the only downside. It's the actual cost of getting rid of the waste afterwards. It's not so much collecting it. That's not too bad. We can do it for about £15 a square kilometre, sorry. We can go a long way for not very much. It's just a man in a machine with a big hoover, basically. It's slightly adapted. It's not that straightforward, but we can do it fairly cheaply. It's the cost of getting rid of the litter afterwards. It's fairly horrendous going to landfill, because we shouldn't be, which is fair enough. There's very few recycling centres that go, yeah, we'd love to take it, because it's just too varied as to what can be in it. It needs to go to a separation unit here first.
Okay, well, thank you for this input. Yeah, I think the biggest take-home message from the seminar is that legislation hurdles are there, and we need to deal with them. And also the litter problem is still a big one. So legislation-wise, I would like to just continue with Henry a little bit more. For the digestate, do you have also the problems that we face here in Belgium? Do you need to compost it afterwards, or there isn't even legislation?
So we on the farm here, we've just got a standard rules permit, which says we can just, as long as we spread it on our farm, it's fine. What I can't do is let it go off the farm. So we've got a compost project here with the solid stuff to sell to nurseries. That I do have to reach the PAS 100 and the PAS 110 markers. So yeah, 70 degrees for an hour and all that. And that's fine, because, the engine's producing 499, it produces heat at 890 degrees. I can do that, again, relatively cheaply on site with the hot water I produce out the engine. So it's relatively inexpensive to do that anyway. It's we've again designed our own one. It's an auger with a few whistles to make sure we're testing everything properly. But again, we can reach the PAS 110 relatively cheaply. So that's not the end of the world. But at the moment, no, we just spread everything on the farm.
Okay.
But what they don't like us doing, using the grass verge, we've got exceptions to the rule each year, which our EA offers. She's not very bright, so we can get away with it going, I need a temporary permit to do it, and she lets us do it each year, but that's not going to last forever. I'm not supposed to be spreading the stuff on my land that's come from the verges, because that's technically not from my farm.
Okay.
They want to charge. They basically it's £20,000 for a year's deployment. So spreading what comes out of our plant for a year, the EA just want to charge us 20,000. They're not saying we can't. They're just going, here's a big bill to do it. The EA here just want to make money. They don't really want to help.
Yeah, well, hopefully Grassification and other projects will help push them into solving this issue so we can use it as a resource. There was a question in the chat early in the webinar that wasn't answered still from Chris Herbout. So he's asking if a farmer would try co-digestion of manuring grass from his farm, would he also have to do the post-treatment or composting step? So maybe Sam or Meet or even Audrey, do you have comments on that?
Maybe I can start and the other can complement, but when we talk about grass clippings from road verges, it's indeed considered as a waste stream, and then you have to do the composting and stuff like that. But when you talk about grass coming from agricultural land, so it's actually produced as a feedstock for animals, then you're not talking about a waste stream, and the digestate composting is not mandatory. So it depends a bit on the origin of the grass.
Okay, so can you clarify a little the legislation? So it's just because grass, a roadside grass, has a waste status, or is it because of the pathogens and the weeds?
It's got a waste classification to it, is the problem. Bizarrely, I can feed it to my sheep, that's fine, but I'm not allowed to put it in my AD plant. That's just the joys of UKEA, but it's because it's a waste that it becomes a problem.
So actually, because Sam mentioned in his presentation about the pathogens and the weeds, but so this is not the main concern. The main problem is just the waste status, or.
I'm actually not sure.
They also give it as a reason, because we asked OVAM also just to clarify the requirements, and pathogens were one of the reasons. But I think maybe due to the possible pathogens, it's classified as a waste.
Okay.
And just, yeah.
Yeah, I was just wondering, because if you look at the requirements stated by OVAM, it's roadside grass, but also nature grass. So I think that for them, it's really the seed weeds and the pathogens that are the main reason. That's also why the entire digestate needs to be treated and not only the tick fraction. So I'm not 100% sure if it's like meadow grass, whether that would be different. We did not ask yet, so that's maybe an additional question that we have to pose to them if it would make a difference. But I think the main reason why they do these conditions is for the weed seed and the pathogens, and I don't think that would be different if it's meadow grass or roadside grass or nature grass, but I'm not sure.
Okay, probably the only difference would be agricultural grass, because then you have a specific species being planted. I imagine it's a much more controlled situation.
You're still not supposed to take it off your farm, though. So we can feed grass into my plant and spread what's on my farm, no problem. What I couldn't do, whether it's road grass or just my grass, is then give it to a neighbour, because they are worried about well, in this country it's black grass, which is becoming a big problem. Albeit I've done a test for E. coli and Salmonella and Listeria for the last 2 years. I still never had any come out of my plants, let alone after we've done PAS 110 on it. And equally, I've never managed to make any weed seeds grow in my digestate, whatever I mix it with, after it's come out of an AD plant. So our AD plant, because we do our hydrolysis first especially, there's nothing alive that comes out of that plant after it's been through it anyway. So I'm not overly worried, but every site's different, which from an EA point of view is a nightmare, because they want one rule to fit every single different plant, which doesn't work.
Yeah, that's exactly my follow-up question. I was going to ask if anybody knows about if you carry on a thermophilic digestion, maybe this would be already enough to kill pathogens in the seed weeds, and maybe we could ask the policymakers to make an exception. But I don't know if this data is out there or not.
Currently, the difference that they make is that if it's a mesophilic condition, then it's 4 weeks of composting, and if it's thermophilic, I think it's 2 weeks, but Sam probably knows better. But that's the difference that they make. Yeah.
So you would still have to go for the composting. Is just
the timing at the time of composting is just different, and they explicitly state that the 1 hour at 70 degrees is not sufficient. So then, because you cannot guarantee that all the weed seeds and the pathogens are eliminated, so they really ask for this at a lower temperature but a longer period of composting.
Okay, but yeah, this is so the point that Henry brought up with the hydrolysis. It's an interesting one. So it might be that just having a different configuration, we might be able to prove that this wouldn't be a problem. So yeah, I think more studies are required, that we can bring the data to policymakers and show that.
Yeah, but not all AD plants do it. So the policymakers would never write a policy for one site. They just want general rules for everyone. That's a slight issue.
You can ask for an approval. So if you can show that with your system that you do eliminate the weed seeds, then yeah, I know. But
we're trying it on our solid part. We're going through that process at the moment. It's painful.
but if you do it, then we can use it.
Yeah.
Maybe just to clarify, in the project for grassification, Anaero got an exception from OVAM. So if you wonder what we did with the digestates, we've attained an exception. So we were allowed to apply the digestate on our own fields.
Yeah, so that's what I've got at the moment for harvesting my grass virgin and spreading on my farm is an exception, which I get each year, but she's not going to let me do that forever and a day. At some point she's going to go back.
Yeah, we didn't find a facility reaching the hygienization requirements and authorized to process manure. So the combination, we didn't find it. So finally we got an exception from OVAM itself.
Yeah, so I would say for moving forward with this technology, more investigations should be done and more focus should be put into the post-treatment of digestate, because as everybody has highlighted, it is possible to digest grass. It might even be beneficial for the process, but then you have a problem with what to do with the digestate, and this is still the current legislation with the information that the policymakers have is very strict, but it might be that it's too strict. It might be that there are options to show that the digestate is actually safe for spreading. So I think this would be an important point for future efforts in this technology. So Bethany, she's also a partner in grassification in the UK, in Kent Wildlife Trust. She made a comment in the chat box. So she said it would make sense for litter picking to be included in the cutting contract for non-trunk roads, or for communication between contractors and district councils to be better, so a litter pick could be carried out before a cut. And I agree, and especially one of the efforts of grassification is that developing a joint procurement process that will also have these specificities. So there might be that the solution is already there, that sometimes the litter need to be picked and you have to cut the grass, and maybe these are just not connected. And it can be a possibility that, is just making the proper connections to make this work. So Natalie De Vriends, she's also a partner in the project. She just made a comment saying that in the Graskracht process, the issue of time and temperature was also examined. So Natalie, maybe you can open your mic and just clarify. Did you examine the impact on seed weeds or just the digestion?
No, I was not examined. Hello, good morning. I was not a person who examined the weed problem, but it was also mentioned already as a problem. And also there some trials were made with the first tank of hydrolysis, etc., to see if that could be a good treatment of the seed weeds. So policymakers know it already for quite a long time. A lot of research was done, but feeling that we are in the same circles again so many years later. So that's a pity. Just so there is no solution yet. Problem is known for long. Tests are done already quite a lot, but same circles are made. It's just what I wanted to mention, that's it's there, it's in the air, and it's not solved.
Okay, thank you, Natalie. Yeah, I think this is a problem that a lot of projects face. You have a very high, long delay between what the data is saying and what the actual legislation is saying. So I think this is a problem over several areas. And it might be just a matter of lobbying and really doing something focused on the policymakers to really let them know what is happening. Because, for instance, it's the same for the fertilizers coming out of manure processing. Only now the legislation is changing, and this technology has been around for several years, maybe decades now, and now it's finally changing. So it is possible, it just takes time. And yeah, we need to put pressure on the right people. I think we're running out of time. I don't know if any of the speakers want to make a final comment or if everything was discussed. No, I think we have everything. So
maybe from my end, Ruben here from Vito.
Yes.
If I may. I think what Natalie says is correct, and things have been in the air already a long time, and putting pressure on policy might help, but the people who need to know are perfectly aware of the issues, and the issue of litter is an issue that won't go away, and they are particularly concerned with further diffusion and dilution of contamination throughout the system up to the fields. So that's, let's say, heavy metal contamination is less of an issue. That's clear for them as well, specifically since lead and gasoline, etc., was, let's say, diverted. But the issue will be the litter, the plastics, and the microplastics specifically are increasing a point of concern. And this won't go away. And they're particularly concerned on how this will be further spread back into the environment. And that's why they allow put it on your own fields. So practically you're screwed yourself. But as both parties said, this will be, let's say, an exception. It was more, let's say, by force than by enthusiast from, let's say, government's point of view. And so I think this litter issue will remain being a problem. I think the pathogens, etc., is something that they also see as an issue, but that they see covered due to the composting. And now the littering is it's on a norm based on mass balance. Like it shouldn't be above 0.5%, or I don't know by heart. But the litter issue will remain an issue. And you may handpick it, but it all comes at a cost. You may say it's an obligation there. It should be in the tender or whatever, but it comes at a societal cost. So that will, I think, remain the issue when you go to policymakers. That's something I encountered. If you bring up the topic, it's clear, but get rid of the litter and let's talk.
Okay, yeah, that's a very...
We didn't find a solution on, and like composting installations have shifters and wind sifters and I don't know, let's say more physical instruments to get rid of this to a certain extent. But if this can be solved, yeah, that's I think the bottleneck for now for policymakers.
Okay, yeah, thank you for the very interesting comment. It might be a middle term solution. Maybe I think Harry also mentioned in his presentation that you find the hotspots of litter and you just avoid, and I think Mite also said that. Yeah, and maybe you can do a first distinction, just do more rural roadside verges. For instance, grassification itself, we did a mowing in Maldeham. It was a very low content of litter just because it's not a road next to anything. So this might be a solution to just kickstart.
Sorry, source separation could be an issue, but it will take some, it will take some time to differentiate, let's say, at the source, like say, excluding some verges which could be included towards material applications, but it won't be that straightforward as we tell it now, but indeed some are much more contaminated. But even in Flanders, rural verges are at least as contaminated as with old bikers, etc. Well, nonetheless, it's an interesting topic at least to source separate, because now we put everything in one big pile.
Yeah. Okay, then thank you, Ruben, for this final comment. I think it was a nice way to end. Margarita, maybe I give the word back to you.
Yes, thank you, Marcella. Actually, I just want to say one more thing that is related to the evaluation form. As you might have seen, I've just shared with you the poll, so we would really appreciate if you can go through it. It will take only a few minutes, and it would be a very important for us to have your feedback on the webinar. And as a last word, I would just thank you all the speakers and the attendees for participating in this webinar. I think it was a very interesting and fruitful discussion. And I would just remind you that Grassification will hold some other events in the next months. So we hope to see you again in future occasions. And from my side, that's all. So yes, thank you all again.
Thank you.